Section 2, Video 1, Radicals. And we're going to evolve a little bit in terms of how we simplify radical expressions. And our focus is going to be on looking for perfect squares or cubes, depending upon what kind of question we have. The remainder will be in the root still, and it will be considered the exact form, and the coefficients are on the outside and being multiplied. Again, none of this is new except for the process in which we are trying to solve them. So when we look at the numbers inside the roots, we're going to look to find factors of the numbers that are perfect squares. For example, and this is just a brief overview before we begin, but if I gave you the square root of 81, okay, now I know that the answer is 9, but I could break this down and say 9 and 9, 3, 3, 3, and 3. One older method of doing this is to write it as 3 times 3 times 3 times 3, and we know that with square roots in groups of 2 they can come out. You're left with 3 times 3 on the outside, and then if there's anything left it would be on the inside. In this case there's nothing left and you have 9. Now the new method is to say, well, what's the largest square that goes into 81? And that's where this list comes in. These are all perfect squares. In other words, they're numbers that we can root. So we want to find factors of a number, or factors of the number inside the root, that we can root. So if you see that 4 can go into your number, or 16 can go into your number, or 9, we can root those numbers. And it makes the process, let's say, a little bit quicker. You have a little more detective work, so to speak. But it is a different way of doing it. Sometimes with really large numbers inside the roots, this is the best way to do it, as opposed to trying to find all the prime factors, which would take a long time if the number inside the root is very large. You can also do cubes the same way. So you would see a cube root, which would say I want to find perfect cubes that go into that number inside the cube root. And again, a perfect cube is a number that you can cube root. For example, the cube root of 8 is 2, the cube root of 27 is 3, etc. So just another way of simplifying radicals. Some would consider it a new and improved way, some would consider it not. But again, the purpose of it is to handle much larger numbers inside the root. If the number is small inside the root, by all means you can do it by finding the prime numbers and going from there. But when you have really large numbers, it's nice to have an alternative method. And we'll go through some good examples in other lessons. And this ends the overview of Section 2, Video 1.